Well, hi there. So in this video, we're going to take a look at the concept known as utility. What we're really asking is how much of one thing should you consume? Which of two things should you consume? And then if you have a budget and you have different quantities of different amounts of things, how much should you consume of those different amounts that would make you the most satisfied? So let's get started. Okay, so the first portion of this lecture is kind of more like a simulation, actually, that we do in class. But there is some information that I want to convey to you at the beginning, which is really just definitions. Utility is this notion of satisfaction. It's this concept that dates all the way back to the 1800s, but it's a way of measuring an individual's satisfaction from consuming goods and services. And we have a kind of a made-up unit for utility. It's called a util. As a stand-in, it's kind of like a util would be like, how much do you value something? And if it's like one util is roughly equal to $1 worth of value. So I would say, like, this pen is a really cool, nice pen that somebody got me as a gift. I don't know if it was $40. The only way that I would be justified in buying it is if the price is $40, is if I got at least that many utils out of it, right? And I wouldn't pay it. I wouldn't pay more than 40 if I didn't get at least 40 utils from it. That's the way to kind of think about this. If I said that, I went to lunch and I bought a burrito for $8, I could think about maybe it gave me 12 utils of satisfaction. And the difference between those two, kind of like consumer surplus, is the $4 of consumer surplus. So a util is kind of a unit of satisfaction. It's sometimes helpful to think about it just as benefit. And that idea of marginal utility is marginal benefit. They're really the same idea. Utility functions allow us to kind of examine this relationship of satisfaction to consumption. There are two utility functions. They're graphed for you. There's a total utility and then a marginal utility. And this is a simplification of what occurs. But what we find in the additional consumption of any good, doesn't matter what good it is, that if you have kind of repeated successive consumption of the units of the good, you're going to get declining amounts of additional benefit from those things. That you're going to say, you know what, that next one, it just didn't satisfy me as much as the first one. Now, certainly there are goods where, you kind of plateau for a while where you're like, oh, that one I just enjoyed just as much as the last one. Haha, gloss, I broke the law. Well, no, you aren't, because you keep consuming additional units. You keep going. Eventually, you're going to have diminishing marginal utility for any good of any kind. It doesn't matter. You can't break that law. Now, at a certain point, the additional units are actually going to make you less satisfied. They're going to make you feel sick because you consumed so many, and you're actually going to have negative utility. So it would be completely irrational to ever consume those units, but it is possible that you could overconsume. You maybe have had that 10th slice of pizza and you're just like, oh, I don't feel good. That's a negative utility. Now, a total utility function just takes all these marginals and adds them together. So we expect total utility to rise as you consume more units of a good. But at a certain point, once you consume that like 10th slice of pizza that makes you negatively negative utils, then actually your total utility function starts to go back down again. So this is kind of a graph that you may see pictures of. It's not too hard to understand what's going on in it. The decreasing marginal utility here refers to what we call diminishing marginal utility. And it is a law just as much as any of the others that we've kind of talked about. Now, three types of utility questions you're going to see in this class. How much should we consume of one good? The second would be, if you have to choose between two, which one should we pick? And then the third is the most complicated one. It's like, let's say you have a certain amount of money and you could buy this much of this, any amounts, and you could buy this much of that, any amounts. What's the amount combination, given the amount of money that you have, that's going to satisfy your needs the most? So that's the tricky one, but it's really not that bad. So let's take a look at these three questions. The first, how much of one to consume? So I did put here the law of diminishing marginal utility is that increasing consumption will lead to lesser utility. See also hedonic adaptation in psychology. That's a cool concept. Go check that one out. Consume until marginal benefit equals marginal cost. This is actually the answer to our question, right? Because we know that marginal utility is going to fall. We should basically consume up to the point where the marginal cost equals the marginal utility and not consume anymore. So let's test that out. Now, at the 0th slice here, we're not going to have any utility or cost, no marginals, because the consumption of this slice, like when we go from 0 to 1, is actually where we're going to get that utility from. And it says we get 8 units. So we get 8 utils of marginal utility. Now, the cost, what's the marginal cost of that first slice? It's not here. Oh, wait, it's right there, $2 per slice. So we got $2 cost and 8 utils. Should we consume that one? Yes, we should. Should we consume the next one? Let's take a look. 1 to 2, 8 to 13, that gives us 5. And how much did that second slice cost us? Well, it still cost us 2. So yes, we should consume that one because 5 is bigger than 2. Should we consume this next one? Well, yes, we should. 2 and 2. And then the next one, actually, we lost a unit of utils, -1. And so we should consume, what do we got? 3 slices because it's marginal cost equals marginal benefit. And the next unit's marginal cost of 2 is greater than the marginal utility of -1. So this is how we would answer this style of a question. We would say we want 3 because that's where it equals each other, and we don't want the next one. It's always important to include why we don't want the next one with these marginal problems. Now, how to decide which 2 products to consume? We compare marginal utility per dollar. Sometimes you've probably heard the phrase bang for your buck. Another way to think about this is like the marginal utility of the last unit that you consumed divided by the price of that product. And so if I was kind of thinking about between 2 choices, you go to WashU or Stanford, MU of going to WashU is 2,000, Stanford's 4. But maybe I get a really great scholarship at WashU, but not so much at Stanford. So I'm going to figure out what's their MU over P. Well, the MU is 2 over 10, so that's 0.2. So I get 0.2 bang for my buck. Utils per dollar is actually how I would read that, right? 0.2 utils per dollar. And I want more utils, right? More utils is better. So then I have 4 divided by 40, so 0.1 utils per dollar. Which one gives me more utils per dollar? WashU. So I would choose WashU because 0.2 is bigger than 0.1, more utils per dollar. Now the last one is how to decide how much of 2 products to consume with a given budget. So the first thing is we're going to calculate the MU over P for both goods, and then we're going to find where those are equal, like find where the MU over P's are equal. And I've actually done this column for us. So we're going to do this column, and then we're going to see where it matches up with this one. And we're going to see if we're using our whole budget. And where that's true is actually where we would get the most total satisfaction. So we're going to see that that's true in this problem. So the MU of the first slice here is 8. The next slice is 7, and then 6, 5. And I'm just going from like here to here to here to here as I'm doing these, 4 and 3. And the price of pizza is $2. So 8 over 2 is 4. Then 7 over 2 is 3.5. 6 over 2 is 3. 2.5, 2, and 1.5. Now, for these values, I can actually work backwards and fill these out, but we don't really need them to be able to do this rest of this problem, right? So I am going to go ahead and fill this portion out, but this next part, we don't need to do it to be able to figure out MU over P's. So let's work backwards. MU over P is 10. I know the bagels were $1, so I know that this MU was 10. And I know that this is the first bagel I ate, so my total utility has to be 10. Now, the bagels were 8 over 1, so 8 from this one, so that one has to be 18. And again, I'm knowing that because 10 to 18 had to give me 8. 6, 24, right? 18 plus 6 is 24. Then 4, so this one has to be 28. 3, this one has to be 31. This one has to be 2, 33. Now, I filled that in really just so I could show you at the end that actually the combination we're going to end up with is the best one for us. So we want to determine our MU over P. We've done that. Find where they're equal, and then use our whole budget. So let's put our fingers down on these 2 columns, and we're going to pick some place in the middle where these are about equal. 2.5, I don't have one of those. I have a 3, and I have a 3. Let's test this combination and see what comes out. So I'm going to put a little dash right here and a little dash right here so that I remember that these are the ones I'm testing. So 5 bagels would cost me $5. And then 3 goes with 3 pizzas. That would cost me $6. $6 plus $5 is equal to 11. And so that's my correct answer. I should consume 3 slices of pizza. I'm getting that from right here. And how many bagels? 5 bagels, because the MU over P, which is 3, is equal to the MU over P of 3. Now, I'm going to point this out. 31 plus 21 is 52. There is no other combination in this entire table out of all of the different combinations of bagels and pizza that you could find. There's no other combination that would give you 52 utils or larger. It doesn't exist. And so that's actually the fastest way that we can do that is by finding kind of that equivalency. Now, one little kind of trick to this is that if maybe these numbers were different, let's say we were at 6 bagels, and let's say we were at 2 pizzas. We were not at the right consumption. What would those numbers be? It'd be 3.5 and 2. And now here's a fun trick. 3.5, right, and 2. So I'm just kind of showing what this would be. This is from quantity 6 bagels, and this is from quantity 2 pizzas. Now, 3.5 is bigger than 2, right? That's kind of obvious. And so I want more pizza. If I wanted to fix this problem, I want more pizza and less bagel if I was at 2 pizzas, and I actually can see that that would fix it. But what's cool is I know I want more pizza because the alligator mouth eats the bigger number, right? The alligator mouth eats the bigger number. So I want more of this one that's giving me more bang for the buck. So if I'm at the wrong combination, I can actually very quickly see how I need to reallocate by going like, okay, the one that gives me more bang for the buck, if the two numbers aren't equal, then I know that I should consume more of that thing and less of the other. Now, rewriting this utility consumption rule is actually, we should find where mu over p is equal to mu over p, and we use all of our income. And that is the simple little rule that we actually just followed right here. We found mu over p equal to mu over p, and we tested to use all the income. So hopefully this helps you understanding utility a little bit better. I'll see you next time.